My name is Ashwani Kumar, and I'm going to teach you today about some basic foundations of deep learning. We will be studying that how where deep learning fits in between AI, machine learning, and other terminologies that we know, because they are quite confusing. After that, we will see that from what a neural network is made up of, because I think you might have heard about neural networks. So, and then we will see the mathematical intuition as well as the geometrical intuition behind the backbone of the neural network. So, let us start. What deep learning is? Deep learning is a subfield of artificial intelligence. Okay. So, it is what? It is a subfield of artificial intelligence and machine learning. So, it is a subfield of both AI as well as ML. Okay. So it is a subfield of both AI and ML. That means if I am drawing AI like this set represents AI and machine learning lies somewhere here. This is a machine learning and this is a deep learning. So here it shows that deep learning is a subset of both AI and ML. Now what is AI? Just a quick intro. AI is, we human beings always want to uh, design such machines that can think like us. What is machine learning? Machine learning is basically, see, you are given a set of inputs, you are given a set of outputs, and you basically try to find the function or the relation between these two. That means if x is our input and y is our output, then a function f that maps x to y. This is the main theme of machine learning. Now, see, deep learning is a subset of machine learning. So, obviously, it does this thing also, but there is a difference. The difference is it depends heavily upon a logical structure called neural networks. It a depends primarily upon a structure called as upon, or simply I will write upon neural networks. Okay, neural networks. Now, as the name suggests, the neural network term is heavily inspired from human brain. Okay, it is heavily inspired from human brain. Now, in machine learning, one more thing is there. The algorithms that are employed in machine learning are dependent upon statistical techniques. They are dependent upon statistical techniques, whereas here we saw that it is primarily based upon the concept of neural networks. Okay, so now let us move forward and let us see that how a very basic neural network looks like. Okay, so let us see the diagram and then I will be explaining everything. So they are layers of perceptrons. We will see what are perceptrons. Basically, they are the building blocks of our neural network. So this is a neural network. Okay. Now, how everything is connected, we will see. Each and every building block that we will see, this is a building block. What I'm saying is this is a building block and this is called as perceptron. This is called as perceptron. Perceptron. Pardon me for my handwriting. And these links are called as weights. These links are called as weights. We will come to them one by one and everything will be clear. So each and every perceptron is linked to each and every perceptron of the other layer. Okay, these are nothing but layers. So here it is getting connected, here it is getting connected. On the same lines, it will be connecting to this, to this, to this, and to this. Similarly, here also each and every perceptron will be connected to each and every of the perceptron of the next layer, right? So it will be like this, like this, like this, like this. Here the picture appears to be a bit clumsy. I'm sorry for it. This is going to be like this, like this, like this, and finally each and everything will be terminated here, and this is the output layer. Okay, so this layer is known as input layer. Okay, this is a very simple diagram of neural networks, and this is known as ANN. Okay, this is known as ANN, that is artificial neural networks, ANN. So this is input layer, this is hidden layer 1, hidden layer 1, HL I am writing in short. This is hidden layer 2, and this is our output layer. Okay, so see, the name deep learning comes from the fact that in more complicated neural network models you are having a lot of hidden layers, so it appears that it is very deep. For example, if there are thousands of hidden layers, so obviously these patterns are very complicated, and that's why we say that it is a deep learning. We say that these things belong to deep learning. So there are various types of neural networks, as we saw. The one is ANN here. Okay, so what here is getting done is, this is the input layer, here the input will come, and these perceptrons are the fundamental building blocks of this neural network. These perceptrons are the fundamental building block of this neural network. Like a brick is the fundamental building block of your home, on the same lines perceptron is the fundamental building block of neural networks. What are weights? The weights are basically that what is the contribution of that particular perceptron in the output. If anything is having higher weight, that means its contribution is going to be more. If it is having lower weight, then it means that its contribution is going to be less. For example, let us say I am giving you an example that there are two factors, let us say IQ as well as CGPA of a student. You are being given the IQ and CGPA, and you are being asked that whether he is going to be placed or not. Then you may say that rather than IQ, CGPA will be a more determining factor on concluding that whether he is going to be placed. That means CGPA is going to have more weight compared to IQ. So I think that I have loosely explained this particular thing. So on the lines of ANN, there are multiple other type of neural networks like CNN, RNN, etc., and each is having a different property for which it is used. Like CNN, it is known as convolutional neural networks, so it is generally used for image processing. Okay, it is very good at image processing. RNN means recurrent neural network. It is very good for speech and text processing. There are a lot more like GAN. This is generative, so it can generate a lot of image data and all. So we will see later on in deep learning course. Now moving forward, coming to the most fundamental thing that we saw, perceptron. Okay, so this was the building block, so we need to know about it. So perceptron is basically nothing but an algorithm. It is an algorithm. Like in machine learning, we saw that linear regression, gradient descent, etc., they were algorithms. So similarly, perceptron is an algorithm and used for supervised machine learning. This is also the building block of deep learning. Building block of deep learning. Now let us see its basic diagram. I will explain that what this diagram means. Actually, I have drawn it for a purpose here. These are inputs here, right? Here it is written 1 and B. Here it is written x2 and w2. Here it is written x1 and w1. Okay, so this is basically doing summation of all these things. Okay, w1, w2 are weights, x1, x2 are inputs, and B is bias. Here it is 1. Here it is written 1. Okay, this is activation function. Activation function. Now we will see one by one what is the need for activation function and what this summation does here. So let us say the output that comes here is z. The output that comes here is z. So from here I can say that z is nothing but z is equal to w1 x1, that means it is being multiplied by w1 plus w2 x2 plus 1 times of b, that is b. Okay. So this is b is nothing but b is a bias. B is a bias that we add to it. W1, W2 are nothing but weights. Okay. X1, X2 are nothing but inputs. Okay. So why activation function is added? We will see it later. For the time being, what we will do, we will assume that the activation function is a step function. I hope you might have studied in class 12th the calculus, differential calculus part. There we saw that a step function is something like this, okay. So if it is y, if it is x, and if our x is greater than 0, then the output f of x is equal to 1, actually this value is 1, and if our x is less than 0, then the output f of x is equal to 0. Okay. So we can, it is clear from this part. So here we are using activation function. So currently you may understand that it is used to bring z in a range. Activation function is used to bring z in a range, say 0 to 1. It may be other thing also, but let us say 0 to 1. Also to introduce non-linearity, to address non-linearity. This we will see. Okay. These are the functions of activation functions. Now the equation that we saw here, z is equal to w1 x1 plus w2 x2 plus b, what it is? We will see it later what it is, just in this class only. Now let us come to the practical aspect. Let us say we are given a problem, and where we are having 1000 students data, okay, and what we are given is the IQ value of the students, the CGPA value of the students, and placed or not. If it is placed, if he or she is placed, then 1, or else it is going to be 0. So let us say we are having a value that for IQ we are having 78, for CGPA we are having 7.8, and it is given that he is placed, that means it is 1. Okay. So similarly there are multiple data will be given, and we will train our model on this. What we will do? We will train our model on this. Okay. Training means like human beings learn from a set of data, from a set of experience. So similarly our function, our neural network will learn from these particular data, and once it learns, the function that we wrote here, z is equal to w1 x1 plus w2 x2 plus b. Okay. So what it will be doing is, by training, the weight w1, w2 and b will be found out. Okay. So the weights will be found out by the training. We will have a value of these weights. Okay. By training, it will come from training part. We will see in very detail that how the training is done and other things. Okay. So w1, w2, wb is, let us say these three things are calculated when we trained our model. So let us say we reached the value w1 is equal to 1, w2 is equal to value 2 and b is equal to 3. Now what we are going to do is, we are going to build a predictor. That means given the values of IQ, given the value of CGPA, you have to predict whether the student is going to be placed or not. So let us say you are having a CGPA value of, you are having an IQ value of 100. Let us say, just for the sake of easier calculation, CGPA value of 5.1, and then I have to calculate that whether he is going to be placed or not. This our predictor will be calculating. So how it will be calculating? Z W1 is 1, so 100 times of 1 plus W2 X2, that means 2 times of 5.1 plus 3 times of 1, that means B into 1. Okay. So it will be giving me 100 plus 10.2 plus 3. This is our Z value. This is our Z value. So this is 113.2. Now I said that there is a step function, activation function is a step. So what it was given to us in the step function, that if our x value is greater than 0, then it is going to be, if our x value or say Z value is greater than 0, then the output will be coming as 1. So here our x value, Z value is greater than 0, therefore the output will be equal to 1. That means the student is going to get placed. A student is going to get and is placed. Okay, so this was just a toy example. This was nothing but just a toy example. Now there are several other activation functions as well. We will study them in detail, like ReLU, TANH. Okay, what we are seeing currently is a step function. Step function. This is the simplest one. Step function. Okay. Now let us see that basically what is meant by W and B. Now we are going to come to geometrical intuition of these things. Okay, we are going to see what is the geometrical intuition behind perceptron. Geometrical intuition. Okay. So the function that I got, Z is equal to W1 x1 plus W2 x2 plus B, and Y is equal to, the output is equal to F times of Z. Okay. What was F? F was a activation function. It was an activation function. Activation function. For our case currently it was an step function. Okay. So if it is a step function, then I will say that this is equal to 1 if Z is greater than equal to 0, and it is equal to 0 for Z is less than 0. Okay. So this was basically whole thing on which we were working. So if you see, you might have studied in coordinate geometry in class 11th, that this is nothing but an equation of straight line. If you replace W1 by A, if you replace W1 by A, W2 by B, and X1 by, let us say, X, and X2 by Y, right, and let us say B by C, if I replace, then it will be very clear that Z is nothing but AX plus BY plus C. So this is what? This is an equation of a straight line. Straight line. Straight line. So our perceptron in this case is nothing but it is a geometrically straight line. So let us say we are having a data like this. We are having a data like this. This is CGPA. On the Y scale we are having CGPA, and on the X axis we are having IQ values, and let us say it is something like this. Okay, these are placed ones. The circle is for placed ones, and this is for unplaced ones. Unplaced ones. I am depicting it like this. So this perceptron is basically trying to draw a line. If you will see that Ax plus By plus C will lie here. So if Ax plus By plus C is greater than equal to 0, then it will point towards this region. That means it will point towards this region. And if it is less than 0, that means if it is pointing towards this region. Okay. So this is the region for Z is greater than 0, greater than equal to 0, and this is the region for Z is less than 0, right. So this is basically the concept of perceptron. Now you may say, if you have keenly observed, then you may say that what if there are some other factors like CGPA, IQ, and let us say I am saying class 12th marks. Okay, let us say, just for the sake, then in that case we will be dealing with a 3D system, right, a 3D system, and here our separator, the perceptron, will be generating a plane. Okay, it will be generating a plane, because in that case your z value will be something like this: x1 w1 plus x2 w2 plus x3 w3 x3 w3 and plus b. So this is basically an equation of a plane in 3 dimensions. So this plane will be generated by perceptron, and it will be basically dividing your whole space into 2 different parts. So from this you can say that perceptron is a binary classifier. Perceptron is nothing but a binary classifier. Perceptron is a binary classifier. Binary classifier. Okay. Now one more thing, see, this is a straight line. So obviously this is going to handle linear data. Let us say I am having a data like this. Let us say I am having a data like this. Okay, and here one another set of data. So can you differentiate them, or can you cluster them separately just by a straight line? No. No matter whatever plane you may draw, whatever straight line you may draw, you will never be able to separate them. Okay. So basically these cannot be separated by linear classifiers. You need non-linear classifiers for this. You need non-linear classifiers for this. And from here you get the birth of, or the origin of, the concept of activation functions like ReLU or sigmoid, etc. Okay. From here the birth of activation functions like sigmoid and ReLU, birth in the sense the need of the activation functions like sigmoid or ReLU comes, because what they do, they basically, whatever your output is coming, z output, they basically map it to a non-linear function, because these activation functions are non-linear. So they make it non-linear. That means your decision boundary, this is known as decision boundary, your decision boundary becomes non-linear. So I think that in this lecture you might have see, just example, sigma is what it is, 1 upon 1 plus e to the power minus x. Why I am saying it here? Because you may understand this, that exponential e to the power minus x. So this alone brings non-linearity to the function. So I think you might have enjoyed this video. Thanks a lot.